Hi, welcome back to part 2 of the accessible data table build. Hopefully you've watched part 1, where after demonstrating the data table, we looked at how you build a generic data table, converting Blazor's weather table into a generic data table that can be used for any data type, not just the weather forecast objects. I would recommend that you watch that video first if you are new to building Blazor components and/or building components that require a parent-child hierarchy. In this instance, a parent that has a collection of column components. In addition, I would also recommend that you have watched the videos on building the pager and debounce filter before this one, so you are not distracted in wondering how they work when we are concentrating on the table in this video. I purposely built and released the pager and debounce filter videos first, as these components are standalone components which can be used in a variety of scenarios, not just for a data table or grid component. The data table component is responsible for sorting, styling, templating and row selections, but is designed to work with other components such as a pager or a debounce text box for its filtering process in a compositional way. As mentioned in part 1, I copy and pasted the components from other builds into this solution, so you have all of the code in one solution should you want to step into any part of the code. The text debounce component required JavaScript for my implementation as discussed in its video, but you can certainly build one without it. The video for the pager build shows code for a non-JavaScript debounce text filter box, if you prefer that. I mention this as I use TypeScript, and as such the component project is configured for TypeScript as well as my usual configuration for Sassy CSS. The pager and data table do not require any JavaScript. I have previously released short 4 to 5 minute long videos regarding configuring Visual Studio for both TypeScript and Sassy CSS. These videos show the same configurations that I use in all of my videos where required. The links to these are within the video description below, as I will not be covering these configurations within this video. Right, let's begin with a quick reminder of the markup that the finished data table uses. We have the data table component showing some of its parameters being assigned starting on line 79. We then have the optional filter tags on line 82, which in this instance contain our text debounce component, but you can put any markup in here. These tags are just render fragments, as we will see shortly. Also, as mentioned in part 1, both the text debounce component and pager component could be placed anywhere on the page. I just added the render fragments so you could place things within the data table's underlying HTML elements. Next we have another named render fragment called data table columns, with its content being comprised of data property column or data template column components, both with parameters and their own render fragments for header and cell templates, allowing for additional custom markup. Finally, we have another optional named render fragment, bottom pager, where we have our paging component. Not shown on this page, but there is also another render fragment named top pager, so you can have a pager above or below the table, or both. If you look at the solution structure, the solution has 4 projects. The bottom one, barely visible, is just a class project for shared classes for the gRPC service. The top project is the hosting server that you get when choosing the web app Blazor WebAssembly project, with the Blazor builds.client project, the WebAssembly part of that template selection. Our main concern is the Blazor builds.components project, which is a Razor library project added to the solution for our components. You do not need a separate components project, but as I mention in all of my videos, I do this so you can see how all of the pieces fit together if you go this route. Having a separate project also means you could output a NuGet package to make it easier to include your components in other projects. As we have used a separate project for the components, one thing that we need to do, as well as adding the appropriate project references, is ensuring that the app.razor file in the server project has the appropriate path to our style sheet. As I use .NET 8, you use the _content/assembly name syntax to access the static resources. In .NET 9, it's the same path, but placed inside a resource assets collection. Now that's out of the way, we can concentrate on the Blazor builds.components project where our data table component is. Starting with the folder structure, I have a CSS and JS subfolder within the assets folder inside the web root, the same as I use in all of my other builds. We also have a related assets folder in the project containing subfolders for our TypeScript and Sassy CSS files. The text Debounce TypeScript file is not covered in this video as it's in its own video. Excluding the partial Sassy CSS files for components brought in from the other projects, we have the usual root and SVG icons partial file with merged items from the other projects. We have a data table partial file, a utilities partial file for a few general classes, and then the main.scss file that just collates the partial files that we want to output to a main.css file placed within the CSS folder. Looking in the root file, we have set a few CSS custom properties, also known as variables, for common property values used within our components. Not shown, but it's the same in all of my other videos. It's the SVG icons file that just contains classes for any SVG icons used. The main Sassy CSS file, as mentioned, just collates all the partial files that we want to be processed and included within the output written to the main CSS file that goes in the CSS folder within the web root. The data table partial file contains all of the classes used by our data table, excluding 4 simple classes in the utilities partial file that you can investigate on your own. I am not covering how the CSS works, but I will point out a couple of things that prove difficult so you do not have to go through the pain barrier that I did. However, if you are stuck with something that Google does not clear up, just leave a question in the comments and I will do my best to answer it. As I use Sassy CSS, for those not familiar with its syntax, the ampersands used are not the same as those in native CSS. The ampersands in Sassy CSS prepend the text after it with the parent selector, which can be nested. For example, $_content when output creates the class data-table $_content, and the $table creates another class for the descendant combinator selector, i.e. the same class just created with a space and table after it. The first difficulty I ran into was trying to have something like a scrollable table body but with fixed table headers. The way I solved this was by putting the table inside a div that had its autoflow property set to auto, so scroll bars would appear when the table exceeded its bounds. That class is the content class just discussed. That was the easy part. The harder part was getting the t-head element to be fixed. I did this by using position sticky with a top of 0. Luckily, position sticky is relative to its nearest scrollable ancestor, something that I did not know. After that was working, I wanted a bottom border on the t-head element, but this is where I ran into problems. A bottom border was visible until you moved the scroll bar, and then it scrolled away, despite the th elements and text remaining. The border still moved when I put it on the th element, with the text remaining in place. I solved that conundrum by using a box shadow that looked like a bottom border. Why it works, who knows. At this point I thought I was out of the woods. That was until I added a spinner that would show over the table rows when sorting or filtering thousands of rows. Initially everything worked perfectly, until I was checking things with the vertical scroll bar, only to discover that sometimes the spinner was not visible. To cut a long story short, just like the borders, even though it was outside of the table and used position absolute, it moved with the scroll bars. I did not initially realise this, as you do not move the scroll bar while the spinner is visible, you move it before, but any movement of the scroll bar altered the position of the spinner. Apparently the issue is something to do with position sticky creating a new stacking and clipping context which affects my spinner's absolute positioning. I wish I could say my solution was due to my experience, but no, it was trial and error using a wrapping class that had overflow set to hidden solved that problem, hence the data table content wrapper class. The spinner's absolute positioning is relative to this wrapper, and the overflow hidden stopped the movement that occurred with the scroll bars. All of the other stuff just worked as expected. The folders Busy Indicator, Pager and Text Debounce just contain those components, each with their own video and projects. Next is another one of my usual folders, the Common folder, with subfolders enums, extensions, models, seeds and utilities. The enums file just contains any enumerations used. For the data table component, we only needed an alignment enum to help choose the alignment classes for the table header and cell content, with the sort direction being a helper for sorting, and the selection mode enum for a parameter to specify which row selection type to use. The utility extensions file just contains some Boolean extension methods, so I can have neat one-line statements where possible, as I get annoyed with the if-else statements, but feel free to convert my usages of these back into if-else statements if you find this a bit bizarre. The all models file is where I would place all simple model types, with one coming from the Debounce filter project. The paging info class is just to bind a pager to the table if pagination is required. The global values file within the seeds folder contains all of the constant values used by the components, which saves me making typos where a value is used more than once. Finally, we have our data table folder for our data table component and its children, the columns. The columns are a little more complex than I would have liked, but there was no easy way of having a header template render fragment available only on one type of column, with an expression func property only available on another, without splitting the column class into two using a base class for the common code. These days I think less about interfaces and base classes and really just try and keep things as simple as possible. As previously mentioned, our column components do not need markup, so I just had our abstract base class inherit Blazor's component base for its event lifecycle methods. This class is inherited by the data property column and the data template column classes. On line 11, and as discussed in part 1, we have a cascading parameter to capture the reference to the parent data table component, which is assigned via a cascading value in the parent. Just ignore the editor browsable attribute, as it didn't work as expected, and as such I have removed it. The cell template is a render fragment that gets passed a tData item, a row of data, for a user's custom markup if supplied. The header style is just a string parameter that populates the th elements inline style attribute with the CSS property value pairs. The cell style is the same but for td elements. The display name is used for the column header title. The format parameter accepts the standard .NET format string to format the data values presented. The alignment parameter is the enum for the column content alignment. The property info property is set only within the data property column class and is used to create a compiled func that helps get the value from the tData object used in the data table sorting method. Having a compiled func to get the data value versus getting the value each time using reflection was around 10 times faster. The sort direction property is just our enum that is used for toggling the sort direction and icons. The public and protected fields are used by our markup but are set in the onInitialize method of the column type. The onInitialize method is a one-time method when the component is first initialized, I tend to use this to raise exceptions for missing parameters or to capture the values of those parameters that probably should not change during runtime. And this instance, it's also used to have the column component add itself to a collection held on the parent. The dispose method is just for cleanup and removes the column from the parent's collection. I have since removed the call to gc suppress finalize as it wasn't necessary. Next, the data property column class. This type is intended only to present and capture parameter values specific to a column that is for data, which can also be sorted, unlike a template column. The data property parameter is an expression func to capture the property of the tData type in a familiar way. The cell style func is a func parameter used to capture a func that returns a string for the style attribute that can be based on a tData item. The isSortable parameter just allows a user to define which columns can be sorted. In this column's onInitialized method, we set the field name based on the property value via a helper method that I forgot to show. We also set the property info that we can use later to create a compiled func to get the data from the tData object for this column. Finally, we make a call to the base class for any other fields to be populated. Next, the data template column, which only has a single specific parameter, the header template, a render fragment for custom markup that can be supplied for a column header. This header template gets provided with the name of the column. In this onInitialized method, we set the field name to a GUID. This was only done as column alignments are added to a dictionary which required a key, so I used the field name, but a custom column does not have a field name, hence the GUID. If the display name value was supplied, we use it for the column title, otherwise we just set it to an empty string. Again, we make a call to the base class for any other fields that need populating. Now let's review the markup, which is all contained within the data table's Razor file, with its C# code being in a separate file. There's quite a bit of markup due to the options, but it's fundamentally the same as what was shown in part 1 of the video. We start with a containing div for our component. The data static attribute is just something I use for my theming. The first nested div is just to contain a title for the table, which is always available to assistive technologies but is hidden from sighted users if the show table title parameter is false. The ID is for an area labeled by attribute on the table, so when the user navigates to the table, the title gets announced. As I wanted the title and filter on the same line, I could not use the table's caption element, as it's not semantically correct just to put divs inside a table element. If the filter render fragment is not null, then its content will be output here. We then do a similar check for the top pager render fragment, placing the markup inside a div that we control. The render fragment in this instance is for our pager component, but it could be any markup or some other pager component. We then get to our wrapper class that I discussed earlier that solved the issue with the moving spinner. If the show table spinner is true, we output the markup for our spinner. Do not forget, Blazor is continuously rendering its response to actions, so it's not a one-time thing. We then get to our div that contains our table. Before I continue, the inline void methods within the code block below were added to try and separate some of the code to make things a little more readable. If we expand the t-head element, we have a for each loop for each column that is within the data table's column collection. If the column is a data property column, then we add any alignment or sorting information to the th element. For accessibility, we set the area sort value to either ascending or descending based on the column sort direction, using a null to exclude this attribute if it's not sorted. Blazor excludes attributes with null values. It should be noted that only one column at a time should have the area sort attribute value of either ascending or descending. We then call the checkAddSortable method that will check if the column is sortable and adds the button and icons accordingly, after which we just continue the loop. If the column wasn't a data property column, we check if it's a data template column, passing the column title to the header template render fragment if it's not null. Otherwise we just output the column title. After we have enumerated all of the columns in the collection, we call the addCheckboxColumnHeader method to add this as the last column if the row selection mode has been set. If you prefer to have the checkbox column as the first column, you can simply just move the if block to come before the for each loop. Within the tBody element, we check if we are using a pager, or if neither pager or virtualization is required, we call the addRows method. Otherwise we call the addVirtualizeRows method. If we do not have any rows in our collection, we just output a row, merging all the cells using a col span with the appropriate no data text message. Once we are clear of the table and its containing divs, we check and output any bottom pager render fragment content. Next, the methods within the code block. The checkAddSortable method, as mentioned, just outputs the additional elements if sorting is enabled. The addVirtualizeRows and addRows methods are almost identical. I really wanted the addRows to be called from within the virtualized component, or just a for each loop for when the virtualized component was not used, but it is not possible just using simple razor markup. I could have used an @code block with render fragments building the render tree manually to negate the duplication of code, but I thought the complexity of that versus a bit of duplication just wasn't worth it. But if you do not agree with that decision, you can certainly change the code. The method starts by both defining a few variables to handle the row selection styles, as well as declaring the virtualized component and setting its parameters. The virtualized component in effect is now our for each loop for row creation, and for each row we set the appropriate classes and inline style property values that may have been provided via a row style func. We also wire up the onClick event to handle row selections using the mouse, passing the handler the current row item provided by the virtualized context parameter. I set the @key directive to the row item just to give Blazor a little extra help for knowing what's changed if rows are added or deleted. Within each row we have a for each loop to create the table cell for each of the columns within the collection of columns. Just like the column header code, we check for the type of column and proceed accordingly. If it's a data property column, then we proceed to get the value using reflection. I should point out that initially I used a compiled func, which I stored in a property on the column, and as we will see shortly, the sorting method takes the approach of using a compiled func. On row sorting, it increased performance tenfold. So why did I remove the code and go back to simple reflection? That was twofold. One, because I had no plans on using the data table without a pager or virtualization, so there wasn't any real performance benefit for my usage. But primarily I did it so you could see the two approaches and choose which approach is best for your understanding or scenario. Just making code faster is not necessarily the best thing to do. What I initially did was within the column onInitialize method, I called a method to create a compiled func, which was then stored in a property so it could be accessed from the markup. The method that creates this compiled func is in the expression utilities class that I forgot to show you, and is the method that is called at the start of the sorting routine. Next, the code just sets a variable to either null or the content from the cell style func if it was used. I use nulls for attribute values, as Blazor will exclude attributes that have no value, but will happily include attributes with empty values. We then check if the column has a cell template render fragment. If there is no cell template, we just create the TD element, applying any classes and inline styles, formatting the data value if a formatting string was provided. We then continue on to the next column. If the column was not a data property column, then it must be a data template column. So we just set the appropriate class and style attribute values, passing the cell template the row item for its rendering. After the for each loop, we check if we need to add a checkbox to handle row selections. If a checkbox is required, we set its checked attribute accordingly, and for keyboard users, we use the onChange event to toggle the selection to be checked or not checked. As the addRows method is more or less identical to the addVirtualizedRows method, I will not go over the code again. The addCheckbox column header just adds an empty header for the checkbox column. It looks like I was having a bad video making day as I forgot to expand the th element, but it only contains an empty span that has an area label attribute with the value from the data table's area select row label parameter. I originally put the area label attribute on the th element, but NVDA, the screen reader that I normally use, did not announce it. NVDA on Edge Chromium and th elements do not seem to play nicely together. The last method is the addCheckbox method, called from the addRows method, and only contains the same code covered within the addVirtualizedRows method. Now the data table code. As this class is a code behind, it should be marked as a partial class using the same name, just appending the .cs extension after the Razor extension, so it's also nested. There are other ways to create code behinds, but this is the simplest. You do not need to specifically inherit from component base, as this is already being done, but you can if it makes the code clearer for you. Lines 12 through 30 are just our component parameters, most of which are self-explanatory. The first couple of parameters are also marked with the editor required attribute, just to warn the user if they forget to add these, although I take it one step further and raise an exception within the onInitialize method if they are not provided. The filter rule is just a predicate that we can use to filter the rows. It should be clear by now what the render fragments do. The default sort column index parameter can be used to specify to sort a column on load, after which the last sorted on column is used. As collections are zero based, -1 just turns it off. The paging info parameter, as previously mentioned, is just used to bind a pager to the data table. The integer virtualize item size px parameter is used to provide a row height value that the Blazor virtualized component uses in its calculations. See the Blazor documentation regarding that. The only thing to note is that I use -1 to disable the use of the virtualized component when paging is not in use. The selected rows parameter and its associated event, selected rows changed, enables two-way binding of selected rows. For example, you can toggle the selection within the component or add and remove selections from outside of the component. The convention to enable two-way binding is to append changed to the parameter name for the name of the event callback parameter. Lines 32 through 47 are just private fields either to capture parameter values when updated values are not a concern, or where the fields are just for decision making. Before showing the code in the onInitialize method and onParameterSetAsync methods, it's important to understand the order of the lifecycle events. Without discussing all of the lifecycle methods, in our case and excluding the setParametersAsync method, which occurs before both the onInitialize method and both of the onParameterSet and the onParameterSetAsync methods, the onInitialize method is called first and only once when the component is first loaded. On subsequent parent renders causing the child to render or changes to the component parameters, our onParameterSetAsync method will be called. Given the above, I will show the code within the onInitialize method first. I assign both the ARIA-select-row label and NoDataLabel parameter values to private fields, which I use in the markup, and in doing so, changes to these parameters would not be reflected within the markup. If you wanted updated values, then you can just use the parameters directly within the markup instead of the private fields. On lines 93 and 94, I set two fields or references, if you prefer, to the data source parameter, as in this component I am only going to be using reference equality to detect when we have a new data source. As most collections do not override the getHashCode method, unless you do this yourself, equality reference is all you have. But in my data table implementation, that's fine. The easiest way to think about this is that a reference equality is only concerned about the container, in this instance a list of tdata, whereas the getHashCode is concerned about both the list and the content of tdata. If you need to know whether the content has changed, you may need to use a hashcode. I say maybe, as adding or removing rows can also be determined by the count of the rows. The row content itself, however, is a different matter. Next, the onParameter setAsync method, and in this component is arguably the most important method to understand. Excluding the sort data source method, which is now much simpler than it originally was, all other methods are pretty trivial. The first thing we do within the onParameter setAsync method is just to set a local variable rowsChanged to false, which is used later. The first if statement checks using reference equality whether or not the data source has changed, i.e., is it a new one from a new fetch, or is it the same as before? If it's changed, we can then clear the selected rows collection and update our data source references. We then call the method checkAndSortLastColumn, which does what its name suggests, and we'll see it shortly. If we are using paging, we then call the checkSetPagingInfo method to update the pagingInfo properties, which in turn updates the pager. The else part is for when we are still using the same data source. However, we need to check if we are using the pager and if any rows have been added or deleted. If the predicate is met, we then set the rowChanged variable to true and update the paging information. In hindsight, maybe this code could be merged with the checkSetPagingInfo method. After this, on line 74, we check if we have a new filter rule or if there are any row changes, as both of these would require applying the filter to the data source. If we do need to apply the filter rule, we call the toggleTableSpinner method that will show the spinner if there's a lot of rows. We then update our private previous filter rule field references to point to the filter rule and update our data source field with a new list created from the filtered data source. As we have just filtered the rows, we call the checkAndResortLastColumn method before turning off the spinner and updating the paging information. Before exiting the onParameter setAsync method, we just ensure that we do not have a null assigned to the selected rows field, and if we are using paging, we get the current page of rows for our markup to use. Next, the onAfterRenderAsync method, which is called after the rendering has completed. If you recall from the first video, we needed to check if this was the first render in order to call stateAsChanged to render the markup after the columns had been added to the collection, given the order of the lifecycle events. But in this instance, we are only checking if we need to do anything if a column sort is required. So you may ask, how do we get the table rendered if stateAsChanged is not called, as described towards the end of part 1 of the video? The reason for this, and something I withhold from the first video, is that there are a couple of things that can cause re-rendering. Event callbacks are one, but more importantly, asynchrony, where control is yielded, will also cause a render to be requested. To solidify this fact, if you go to the step 3 component code and add an onParameter setAsync method with just an await task.yield statement, also commenting out the call to the stateHasChanged method within the onAfterRender method, everything works fine and the table is rendered. The reason I did not say anything in the previous video regarding the yield of control was so you could understand some of the nuances and fixes, such as using statusChanged, as when I first started building components where I needed to add things to a parent collection, I was initially completely stumped as to why nothing was being rendered. Unless your code does something that automatically causes a render request, it's important to realize that you may need to do this manually via statusChanged. The check and resort last column method, given a data source which could be either the original or filtered one, and a column index that is not -1, just calls the sort data source method. The check set paging info method, again given the original or a filtered data source, just updates the paging info object accordingly. The add data tables column method is predominantly for adding columns to the data tables collection, but in this instance I also chose to get the alignment class and then store it in a dictionary to negate doing this check potentially thousands of times on every render. I should have really added class to the constant names as I normally do, so it's a bit clearer when reading. The remove data table column does what it suggests and is called when the column component is being disposed, although I doubt it would make much difference if you did not do this. I just prefer to clean up where I can. Next, the handle column header click method. This just checks if the column is sortable, and if so, calls the toggle sort data method using either the original or filtered data source. If paging is used, we then get a page of data to be rendered. The toggle sort data method first calls the toggle table spinner method to have the spinner shown dependent on the number of rows. It then just sets all columns to be unsorted, after which it sets the column to be sorted to either ascending or descending depending on the current state. The sort data source method is then called, followed by turning off the spinner if it's currently shown. The method then returns the index of the column just sorted. The sort data source method is somewhat simplified to what it was. I tried various things in the hopes of getting better performance, including manual sorts, custom comparers, using array.sort, as well as other things, but ultimately the simplicity and performance characteristics of what is shown proved to be adequate for my needs. We are not only doing a sort, we are doing a sort on a copy of the data and using the results of that sort to reorder the original data source. I needed to do this as I chose to use reference equality for checking data sources and row selections, and just doing a toList would have returned a new list, not the original, which would cause problems for both of these. The biggest takeaway from this method is on line 178, where we call a method to create a compiled func, which is then used to get the values for sorting as shown on lines 182, and in this instance on WebAssembly proved to be 10 times quicker than using reflection. The getDataPage method just returns a page of data using link, skip and take methods. There's not much else I can say about this one. Next is the handle on select row method, which is the click event handler for row selections. If the selection mode parameter is none, we can just exit. If our collection of selected rows already contains the row passed in, we remove it, otherwise we add it, as the handler is for both add and remove. We then just check if we are using the single selection mode, and if so we can simply remove all rows excluding the one just added. Again, just to reiterate, this process is also done via reference equality. Finally, we raise the selection row changed event with the collection of selected rows, which will be one or none in the case of single mode, or none or one or more with multiple selection mode. The toggle selection method is the equivalent of the previous method and is the handler for the onChange event on each checkbox to simplify selections made with the keyboard. Although I'm not going to do it now, I think the method name toggle selection was not the best choice. Maybe something like handle row selections and handle checkbox selections would have been better choices. Next up is the toggle table spinner method, responsible for showing and hiding the table spinner during sorts and filters if there are 2,500 rows or more. Sometimes with Blazor, when you want multiple renders, as is the case with a spinner, where you need both a render to show it and another to hide it, isn't always straightforward. And what you expect to work every time, sometimes it just doesn't. In this instance, using an await task.yield, which although releases control and as such per the Blazor documentation should allow a render to occur, did not always happen, as I noticed that on the odd occasion when clearing a filter that the spinner did not show. To remedy this, I had to use a 1 millisecond task.delay. To date, I have not found a comprehensive explanation regarding this, and as such I am unable to explain this to you properly. If I eventually figure it all out, I will leave a comment in the repo, but let's just say, don't hold your breath. The build classlist method is just a helper for the markup to strip out white space when a class may not be required. The getAlignment class method is another helper for the markup, and in this instance is just getting the alignment class name out of the dictionary where we stored each column's alignment when adding the column to the collection. Finally, we have the getSortIcon class method, which just returns the class name for the icon to be used based on the sort direction. And with that, we are done. As usual, you are welcome to leave good or bad comments, and I will do my best to answer any questions raised. Please let me know if there is any specific component that you would like to see that as yet I may not have covered. You will find all of the links for the source code or links to related builds and videos are within the video description below. Until next time, bye for now.